Okay, welcome everyone to our first community conversation of 2026. My name is Alicia Jungord. I'm the newest member of the PCEC team, and I'm really excited to see you all here today. In my new role, I serve as the Director of Education and Advocacy here at the Park County Environmental Council. Before we begin, I want to acknowledge that what we now call Park County has a long tradition of human habitation. We reside on the traditional homelands of many indigenous people, including the Cheyenne, Blackfeet, Sioux, Absoliga, and many other indigenous nations who still live here that are deeply connected to this land and whose ancestors cared for and stewarded this place. We are committed to finding ways to work together and to honor this legacy for future generations. For those of you that are new to us, PCEC is a local place-based conservation organization dedicated to protecting the land, water, wildlife, and communities of the Yellowstone Northern Gateway. We are working to create a more resilient future where all life can thrive. Like I said before, this presentation is being recorded, so please mute your microphone. There will be some time after both presentations for a little Q&A and discussion. You can also drop comments and questions into the chat window. To help me with today's conversation, I want to introduce you all to this year's Barbara Hayes Fellow and Big Sky Watershed Corps member here at PCEC, Taylor Brandt. Taylor moved to Montana in 2019 to attend MSU, where she earned a bachelor's degree in environmental studies and writing with a focus on science communication and sustainable community development. Welcome, Taylor.
Thank you, Alicia, for the introduction, and thank you all for joining us today. When Alicia asked me to help out with this community conversation, I was stoked to help provide a platform for community members to contextualize what is going on with our snowpack. I am an avid skier and have been in love with snow ever since I can remember. I was 16 years old when I dug my first snow pit. At the time, I was only analyzing the stability of the snow to determine where slopes were safe to ski on, and I had no regard for what the snowpack meant for the watershed I was living in. However, in the past few years, my understanding and appreciation of snowpack has evolved to include its key role in our watershed. Snow is more than a playground, it acts as a crucial natural water storage and accounts for the majority of our water supply. The snow that falls in the winter sustains our groundwater, wetlands, and rivers throughout the year. Knowing the important role that snowpack has in our watershed has me feeling concerned looking at the green grass in my lawn. One of my favorite conversations to have with people is about the weather. Lately, those conversations have gone along the lines of, when is it going to feel like winter? Maybe it'll snow in March. In my first week at PCEC, I helped send out an email reminding folks to water their trees in January. This is not something I imagined I'd be working on during a Montana winter. And it looks like we're going to need to water our trees again, with temperatures reaching into the high 40s this week. We have been experiencing record-breaking high temps for this time of year. The ground in the valley is bare, yet the official data shows that the Upper Yellowstone watershed is sitting at very normal levels. Based on the weather and winter I've been experiencing, these reports of normal snowpack levels feel fabricated. Today, we want to bridge that gap between what we see in town and what the sensors are reading in the mountains. We will never be able to control the weather, but we can strive to understand what it means and the impact it'll have on us and our ecosystems. I'm very excited to have guests Eric Larson and Dr. Cathy Whitlock here with us today to discuss this abnormal winter weather we've all been experiencing. Eric Larson serves as the Snow Program Manager and Hydrologist for the USDA NRCS Montana Snow Survey Program. Over the past 12 years, he has specialized in maintaining and installing snowpack measuring stations called SNOTEL sites across the mountains of Montana and northern Wyoming. When not in the field, Eric analyzes snowpack and water supply data, translating complex information into accessible insights for wide-ranging audiences. Outside of work, Eric enjoys embracing Montana's outdoor wonders. In winter, he and his wife Alicia and their dog Indy spend their time skiing. During the summer, they can often be found exploring Montana's rivers, home to the water Eric measures throughout the snowy season. Handing the presentation off to you now, Eric.
All right. Hello, everybody. Let me share my screen here. Yeah, thanks for the intro, Taylor. I can't agree more with what you said that the snowpack numbers probably seem fabricated to everyone this year. It's certainly been an odd year. I kind of miss the all the snow in town, and the skiing has kind of been not the greatest. So that's why I'm here today, to talk about how those snowpack percentages are calculated, what they're used for, and so forth. So kicking it off here with this first picture on this first slide. It's That's Yellowstone Park taken in December, and it just kind of shows like, hey, there is snow out there right now in the mountains at elevation. Quite a bit of snow up high, actually, but it's also showing too, like in December, how warm it was. This is the outlet of Yellowstone Lake, of course, and just with the open water there, you can see how warm it's been. So I'm going to break this into two sections. So this first section is going to be about like the data collection, why we collect the numbers, how we collect it, where we collect it, how the percentages are calculated. And then I'll dive into the actual snowpack conditions and the hydrologic conditions this year. But yeah, this photo right here is the newest snowtel site in the state of Montana, Mill Creek Snowtel, which was installed last summer. So yeah, we most of you have probably heard of Snowtel sites before. They're automated out and they're producing hourly data, collecting and transmitting hourly data. Their standard sensors are snow water equivalent, so the inches of water in the snowpack, snow depth, air temperature, precipitation both in the form of rain and snow. So if it snows in the precipitation gauge, there's antifreeze in there, it'll melt it and that level will increase. So yeah, Snowtel's been around since like the 70s when that technology became available to automate things. Snow courses are a little more historic. They were first established in like the 1920s, and there's a big push to establish more of them throughout like the 1920s through the 70s before Snowtel came around. So yeah, we measure snow courses monthly. Kind of pointing this out because it depends on when you're looking at the data. If you're looking at it on the first of the month, you'll have almost double the data set for a particular watershed like the Yellowstone. So just keep that in mind. In terms of where we and how we like lay out our network of snowtel and snow courses, this is what I'm trying to get at here. I'm going to start with this chart on the lower right corner here. So yeah, we got elevation right here. You got area of the watershed below that particular elevation, cumulative precipitation right here. So the main thing is, as you can see, is the slope of this line, particularly for the elevation line, which is blue, is flatter. That's taking up more percentage per elevation band. So based off that, if you're looking at the Yellowstone above Livingston, then we can say that 73% of the Yellowstone River Basin is at that elevation band of 7,500 feet to 9,500 feet. You know, I understand if you went further down, like to Billings, that number would change quite a bit. But I kind of selected this because most of you are, that's, above Park County, but also just like most of our water is coming from our mountains anyways. So that's what that's showing. Most of our elevation and precipitation is within those elevation bands. And then this map over here is just showing the largest tributaries or contributors for producing most runoff, both off elevation and precipitation for the Yellowstone above Livingston. So the darker the blue, the more precipitation. And we try to put our snowtels and snow courses within those basins. Sometimes access is challenging, though. I mean, there's always that component of how you're going to get a site in and get to it to maintain it once a year. All the diamonds, of course, too, are all the snowtels and snow courses. Same thing for the Shields River, being in Park County as well. Shields River. The thing about the Shields, it's significantly shorter than the Yellowstone, at least above Livingston. Most of that basin is more valley elevations. It's a hard one to monitor. You got coming in from the west, Brackett Creek, which we have monitoring, but then the Crazies. South Fork Shields area, and then Forest and Eagle Lake. The crazies don't have the greatest monitoring. Access is just kind of a challenge. You probably have to use a helicopter to get into a lot of the locations, which isn't out of the question, but just throwing it out there, it's kind of challenging in the Shields River in terms of that watershed for monitoring. So the main purpose of the snow survey program is for water supply forecasting for agriculture. Agriculture is our largest consumer of water in Montana. And so, yeah, we've been doing this a long time, forecasting that water. So we forecast total volume of water over like an extended period of time. So this is an example, May 1st forecast for that volume, that the flow that'll pass a certain point on a river for that time frame. And we forecast in thousands of acre feet. And so what this is showing is the total volume right here. Our forecasts have ranges. So, there's a chance it could be anywhere from here to here. If it's normal precipitation ahead, it's most likely going to be in this range for volume. If it's really wet after that forecast is produced, it might be here. So this is
Eric, I think you might have froze. Is this happening for anybody else?
Yes.
Oh,
Yes.
okay. Hopefully he can get back on in a second. I just texted him. Hopefully, does anybody have any questions on what he's been saying so far?
Hey, I'm back. Sorry about that.
Okay.
Let's see here. My coworker's watching. He just walked in and was like, "Oh, I lost you there." Sorry
Okay,
about that.
back at it.
Back at it. Okay, so I'm not sure where he lost me, but I'm gonna just leave it here at the shields is like the successful rate of the forecasts. A lot of times there's precipitation after this May forecast comes out, so it might put that into that range there, and so forth. So what is the snowpack percentage? It's an index-based system. It's essentially just showing the current snow water equivalent divided by the median for that specific day. So it's not a representation of the entire season. If you're looking at it on April 1st or May 1st, it might be more of like an indication of how much snow it is of what accumulated over the season. But it's not uniform across the basin. If it's basin wide percentages, you can get percentages for stations or basins. But if it's basin wide, then it's represented on a chloropleth map, which I'll show you next. Not always an indicator of peak unless you're looking at that springtime. But main takeaway: contextual indicators. It's just one piece of the puzzle. They're kind of produced because it's easy to see what's going on. There's so many variables coming in. So this is kind of like a one kind of number you can look at and kind of get a picture of what's going on. And so chloropleth map is essentially a map with fixed boundaries. That's what our snowpack percentage maps are. So we always have our fixed basins. It's not to say like the snowpack, even though the snowpack in the Yellowstone, for example, right now is above normal. It's like obviously not above normal in the valleys and such. But yeah, so it's not the same. You can look at the chloropleth, non-chloropleth, the dynamic boundaries. Generally better for like when you have more dense data, essentially. And just given how sparse some of the SNOTEL network is, we're kind of stuck using these chloropleth maps. All right, looking at how the snow percentages are calculated. So this is for January 1st, and I just did this one because I wanted to show you how many snow courses there are within the basin and how these numbers are calculated. So if you're in our interactive map, click on a basin, this dialog box will pop up. You can click on the plot right here, or you can open up a little tab to show this right here, which is essentially this. So the way they're calculated is it sums up all the observed and And then it sums up all the median values for that specific day. And then it divides the two. And then that gets you your percentage. And like in a way, this almost kind of weights the snowpack percentage based off the areas that are getting the most snow and have the largest medians. For example, you might think on May 1st, a low elevation site potentially might have 1 inch or like a tenth of an inch of median. But then if it had 1 inch of SWE, that'd be 1,000%. But that's only 1 inch higher than the median, zero point 0.9 inches higher. So it wouldn't throw off this overall number that much. But yeah, and then we're also using medians just because medians, uh, they naturally just kind of throw out the outlier years. You're finding that middle value essentially. Okay, so looking at the hydrologic conditions for this year, this was taken last week at a Gardner Yellowstone Park webcam. Just illustrates this year really well. It's a lot of snow in the mountains, and it's just brown and dry down low. So you can't talk about snowpack without looking at precipitation. So this is water year precipitation, total precip from October 1st through yesterday morning. And it's been very wet this year, as you can see here, despite the fact that it's been so warm and it's been raining rather than snowing at a lot of elevations. It's been very wet. So this is just kind of showing where our percentages are at for both the Shields and Yellowstone above Livingston. This map in the middle is ranking all that total volume of the total inches of precipitation compared to its entire period of record. So like you're seeing all these stations across the basin that are like second highest precip, third highest, second. You get up here more like the 10th. And that's what some of these numbers are showing too. So Fisher Creek, third highest in 48 years. And then you can kind of see some of the other years to compare it to. 97 was obviously a huge year, but we're not too far behind 97, honestly. And Brackett Creek and the Bridgers. Fisher is near Cook City, Montana, by the way. And then Porcupine is up by the Porcupine Cabin right here. So just another way and another example to look at precipitation. So this is Parker Peak in the headwaters of the Lamar. So start of the precip record going back to 81 here. Black line is this year, top the daily maximum. So not a given year, but the maximum from every day of all the years plotted on there. And they got the median, and the minimum. But yes, that's where we're at this year. Second highest is what that's showing. And then comparing that to 2017, which was actually the biggest year at Parker Peak rather than 97. So, and then some totals across the basin there for precip. The nice thing about all the precipitation is it has recharged our soil moisture a little bit. This is a good thing, especially when you start thinking about runoff efficiency and snow melt in the spring. If things are really dry, it'll suck up that snow melt into the soils initially. But yeah, so we're in like the higher percentile, near record high or soil moisture in these areas, and because of that, we're in fairly good like non-drought conditions, except for that northern tier where it's abnormally dry in Park County. And then switching over to the snowpack, where this map on the left again was end of December, January 1st for snow courses and snow tells. So 132%, kind of hard to believe. Shields is a little bit lower, maybe partially because we're missing some monitoring and part of the crazies. But then just some highlights from that. And then every day it's not accumulating snowpack. Those percentages are dropping because that median for each day it is increasing. But yeah, snowpack is a little bit lower in terms of or lower elevations because of that rain snow line. Those percent.
Well, shoot, it looks like the internet isn't as great in Belgrade as it is in Livingston today. Hopefully Eric will be able to get back on here right away. Yeah, sometimes it will help. I have a feeling that it might have to have something to do with his internet at his.
Sorry about that. Here I am again. Just keep getting booted for whatever reason. But I only got two more slides, so I'll finish this off quick here.
Thanks, Eric.
Sorry. And so, anyways, some snow water equivalent on the left axis, snowtail sites ranked from low elevation to high elevation. So 5,900 feet to about 9,400 feet. So gray is the normal value, current is the current SWE. So you can see how high above normal we are at this elevation band. And everything down here is really low. So essentially, if you think of that, kind of the elevation distribution, like this portion is currently outweighing the portion down here in terms of overall snow water equivalent within the basin. So uh, that's where we're at for that. And then just a quick summary here. Near record high precip since October 1st. Soil moisture is very saturated. The downside of lack of snow in the valleys is potential soil moisture loss. Snow helps lock in that soil moisture so it doesn't evaporate. So we're a little concerned about that. You got the elevation distribution here because of the high rain snow line. Things are well below normal down low. Snow depth is currently
Oh man, what a bummer. Um, yeah, I think he'll be able to get back in. I do know that this is his like last like informational slide. And so hopefully he'll be able to answer any of those questions that might have been messed up based.
we can make up from. So that's where I'm at. Stop sharing here. Sorry for the connection issues.
Oh, well, thank you, Eric. That is not something that you had control over, so we really appreciate that. And how interesting to learn about the different elevations in our river valleys here, in
Ali-
Park
Alicia,
County.
can he go through just the last couple bullets, just because that audio
Yeah.
was cut out?
Yeah.
Just I'm
Eric, I
just
don't know
thinking,
if you know this, but you cut out again on that last slide.
Of course you can. Yeah. Let me make sure I'm sharing the right screen here.
it's because it's the wrap up and the summary, and it is recorded, so we'd love
No,
for
I'm
it to be
glad.
on
Thanks for,
record.
yeah,
Thank you.
yeah. So you asked me to go through the last couple bullets again. The main point was, that you got the elevation distribution within the snowpack, near record low snow depth at those lower elevations, but upper elevations, like particularly near Cook City, near record high depth in early January at some of those stations. 2 to 3 months remain in the snow water equivalent accumulation season. We have some surplus up high. These are our deficits down low. So if it snowed, 2 inches of SWE in the next like 3 weeks, we might be pretty close to normal even down low. It's not looking like that would happen given the forecast. But just saying there's time left. It certainly needs to snow a lot more. We're not even close to our normal peak, springtime peak levels. But if it does snow soon, there is a chance we could make up. Hope that was helpful.
Yes, that was wonderful, Eric. Thank you. And like I said, yeah, very interesting stuff here. So now we're gonna turn the conversation over to Dr. Cathy Whitlock. Cathy is a Regents Professor Emerita of Earth Sciences at Montana State University. She is nationally and internationally recognized for her research on the climate and environmental history of the American West, and she is lead author of the Greater Yellowstone Climate Assessment and the Montana Climate Assessment. Dr. Whitlock provided vital testimony on climate change in the Held v. the State of Montana case, and she currently co-produces the series Montana Climate Matters, which is appearing in newspapers across the state. I would like to extend a warm welcome to Dr. Cathy Whitlock.
Thanks, Alicia. Hi, everybody. Thanks for having me today. Let me share my Slides. Does that work? Yes? No? Yes. Okay.
Yes.
Yeah, so Eric gave you the details of what's happening, and I wanted to talk a little bit about the trends, the long-term trends, and also some of the projections for the future. Um, it's really been an interesting year, I think. First of all, we're on this warming trend. This is the rate of temperature change in the US, and Montana's warmed as fast as any state in the country. The West is warming faster than the East, and we're warming because we're a long ways from the coast and we're high elevation, and we're also a northern state, and northern latitudes are warming faster. Um, Let me start by telling you where I get information and that you might check. The first is the Greater Yellowstone Climate Assessment that I was involved in. And I recommend this because it's a good description of what's happened in the past and what the future trends are. And it gives you a lot of background information on how those were developed. It's also a watershed by watershed look at climate change. When I want to get future projections at watershed levels and even down to county levels, I go to the USGS site, their National Climate Change Viewer site. It's got great information, and it actually will download reports for you for particular counties. So I recommend that. And then it's still functioning, but it's slow, and sometimes it's down for repairs. But the NOAA NCEI sites give you kind of the historical trends. So that's where I go to see what the long-term trends are for counties, for watersheds, for states at a national level. And this is the Park County trend that I downloaded. You can see the blue line is the trend, and compared to the average for the 20th century. We've been warming at about 0.2 degrees Fahrenheit per decade, and so we are now 2 to 3 degrees Fahrenheit warmer than we were in 1900. So we're part of the warming trend, and you would see that trend anywhere in Montana. You would see it. It's generally what's happening in the country. So those are my sources of information. Now, there's a couple of things going on, as I understand it, this year that are making the weather kind of weird. First of all, is we're in a La Nina phase of climate. La Nina is interannual variability, and it's driven by conditions in the Pacific. NOAA says that we're moving out of that, but La Nina typically makes it colder and wetter in the northwest and dry in the southwest. Now, statistically, La Nina El Nino patterns are not statistically strong in Montana. We're sort of a long ways from the forcing, and some years show just the opposite pattern than would be predicted. But if you look at this map, I was really struck by this. Just looks so much like the weather maps we've been seeing for the last week, right? Where we have this big blocking high off the coast that's affecting the weather of the west. In the meantime, it pushes the jet stream in a position that brings storm tracks across the country and into New England. And it also sets up the stage for these big incursions of polar air. So this kind of La Nina pattern is is consistent with the kinds of weather we've been seeing of really dry conditions. And the prediction is that the 3 months prediction is that La Nina is going to continue for a little bit, and eventually by summer maybe be gone. But that's going to bring colder temperatures and wetter conditions to our state. So I went to the NRCS and downloaded the precipitation map for the West. So here's where we are in the red triangle. But it's interesting that the entire West really is pretty close to normal or above normal in the amount of precipitation. In other words, we've been getting a lot of precipitation this year, everywhere, even in the places that are supposed to be dry. A lot of that precipitation, especially in the northern Rockies and in the Pacific Northwest and Northern California, has been driven by these atmospheric river events. Now, you probably know atmospheric rivers are these long filaments of water vapor that start in the tropical, subtropical Pacific Ocean, and they carry an incredible amount of water with them. And then they hit our coast, and as they rise over mountain ranges, the air masses cool and brings rain or snow. They've clobber California, but they also get into our area as well. It's estimated that these storms, these kinds of systems, bring 90% of our moisture, including the big storm event we saw in December that caused major flooding in Libby and brought most of our snowpack to this region. That was an atmospheric river. And research is being done now that shows that these kinds of systems become more frequent during warm periods. Now here's the snow water equivalent for the West, and it has a different pattern than precipitation. It shows this high amount that we're getting in our region and up in the northern Rockies, but the snow water levels are astonishingly low for the Pacific Northwest down into California and the Southwest. They're still getting very, very low snowpack. So what's the deal? This is probably a signal related to warming temperatures from the La Nina, but also from climate change. When you look at the temperature trends in the greater Yellowstone area since 1950, we've had this 2.3 degree Fahrenheit warming that I showed you from the Livingston data or the Park County data. Sure, we've had warm years and cold years, but in general, the trend has been towards warming. Now, 2023 was the third, or 2024 was the third warmest year in Montana. We've had warm years globally. 2024 and 2023 are the warmest years on record. The last decade is the warmest decade ever recorded. We're just simply getting warmer. And also what's happening is mean annual snowfall is decreasing. This is measured primarily at weather station data. So snowfall is just accumulation from storm to storm. And most of the weather stations are below 8,000 feet, and they're showing a really kind of an amazing loss of snow since 1950, as much as 24 inches of snow. About 25% of snowpack has declined at middle and low elevations in the greater Yellowstone area. And you can see this trend is really across the West, as shown in the 5th National Climate Assessment. The top graph shows you April snowpack or SWE. The red circles are where there's been a decrease since 1955 to 2022. And the bigger the circle, the bigger the decrease. And you can see almost all of the measurements taken in Montana show this general decrease in snowpack. The timing of peak snowpack comes earlier and earlier, shown by the red dots versus the blue dots in the lower left. And the length of the snowpack is getting shorter and shorter by days since this measurement was taken in 1982. So basically, we're losing our snowpack because it's getting warmer. The other thing that's really characterizing our climate is not so much that we've gotten drier or annually. Actually, annual precipitation hasn't changed and slightly increased in many places, but in Montana. But what we're seeing is a change in the timing of precipitation. So if you compare now with 1950, what you see is that winters are drier, noticeably drier than they were in 1950, whereas springs and falls are wetter. And I think that we've seen that in the last few winters, that it just takes forever for the snow to come. And then we get these really wet springs. And then you go into summer being dry again. Now, climate change isn't anything new in our region, right? But I want to just point out that the temperature differences between how much snow we get really isn't very great. So if you think about the difference between an ice age and now, it's only about 9 to 10 degrees Fahrenheit difference in temperature to make the greater Yellowstone look like the picture on the right versus the picture on the left. That's not very much, 9 to 10 degrees Fahrenheit in annual temperature. We've been doing work on the Beartooth Plateau, looking at these ice patches, and it turns out these ice patches, they're not glaciers, they're just stable bodies of ice that persist from year to year. They're very old. Some of them go back 10,000 years. And we've been taking cores in these ice patches to see what the history, what the climate history is of those ice patches by looking at the chemistry and the debris that's in the layers. So up here you can see the crew standing here with the drill rods taking cores. This particular ice patch in the Beartooth is about 6,000 years old. We know from radiocarbon dating. And if you look at the margin, you can see all these logs. Now what's happening is, because it's getting warmer, this ice patch is melting. And as it's melting, it's revealing what was buried when the ice patch formed. These logs are white bark pine. They grew about 5,900 years ago, and tree line was 600 feet higher. So this area of ice patch and tundra was covered by forest. And that happened with about a 2 degree Fahrenheit warming. Tree line was about 600 feet higher. The climate started to cool long term, and the ice patch developed and buried the forest. So it doesn't take much temperature change to really affect the amount of ice and snow that we get. And then there's the Old Faithful story. Old Faithful stopped erupting during a warm mega drought from 1233 to 1362. It just stopped, and trees actually grew on the cone of Old Faithful. The reason it stopped was there wasn't enough snowpack at that time for the groundwater to come into the plumbing and get pressurized to cause geyser eruptions. So even on decadal timescales, we can see that changes in climate have a big impact on snowpack, on precipitation, and the ecosystems that depend on it. The future projections for snowpack are for less and less, really. So the black line is the historical data going back to 1950, and the red and the blue line are two projections for the future based on rising temperatures. So you can see that it's a pretty significant loss of SWE. The red line, I used to think was a sort of extreme case, but who knows anymore. And the blue line is the line if everyone followed the Paris Agreement commitments that they made. And you can see that up to 1950, it really doesn't matter which climate projection you're following. We're just losing snowpack. And the Yellowstone assessment we presented this as a figure. So this is the ecosystem going from 1950 to the end of the century on the bottom. And on the side, it's plotted elevation. Yellowstone is this range of elevations, Yellowstone National Park. Blue is the elevation where snow is predominant. Green is the elevation where rain is dominant. And the yellow, orange, and red is slush. It's rain-snow mix. It's really wet snow going to kind of rain-snow, intermittent, trading off. What we see is that simply because temperatures are getting warmer, the elevation of snow dominance increases through time. And so that in 1950, it was at about 7,000 feet. But by the end of the century, it's projected to be up towards 10,000 feet. And in the meantime, the slush elevation gets broader and rises, as does the rain dominant elevations. If you put that in maps, it looks like this. So blue is the snow dominant. Here's the greater Yellowstone ecosystem. And you can see the way it looked in, say, 1990. This is a projection for 2030, not too far wrong. Here's 2050, 2070, and this is the end of the century. So this is really quite a concern because we're losing our reservoirs of water that provide help sustain us through the summer. I guess just to close, I'm despondent. There's this persistent and pernicious, I guess, gap between people's understanding and attitudes towards climate change. This is survey data from Yale University. Most people understand that global warming is happening, and that percentage, 74%, really reflects a rise that's happened every time they've done the survey. But when you ask people, will global warming affect me? It's only 45%. It's a much lower percentage. And so we have not done a good job of explaining to people that climate change in our region is affecting our environment. It's affecting our property and our property values. It's affecting our health. It's affecting our livelihoods, and it's affecting our lives. And I think that's where the mission is for us, is to really make people understand what's happening. And so I've been thinking about what can you tell folks about climate change? And I think one message is that climate is not weather, but climate change is supercharging weather events. These atmospheric rivers are stronger than ever. We've seen spring floods, we've seen huge wildfires. I mean, the list goes on. Current climate change is unprecedented over the last 20,000 years, and I can confirm that. We just don't see the trends and the warming in the past that we're seeing now. And this is affecting Yellowstone's ecosystems, and the changes we see in the ecosystem really represent environmental changes and species changes as they adjust to this climate warming temperatures and snow loss. And the final message we have to give to people over and over is that climate change is a problem that we can solve. And the solutions actually are cheaper, they're healthier, they're local, and they're cleaner. And so I guess I appeal to you all to think about selling this message, because what we're watching now with our snowpack, I think, is got a climate story to it that is a result of our actions. So maybe I'll stop with that.
Thanks.
Oh, thank you, Cathy. Yes, thank you, Cathy. Thank you, Eric, very, very much. What a wealth of knowledge you both are. Um, we have some time for some Q&A right now. I did see that Bonnie Hickey Bonnie Hickey put a question in the chat. It looked like it was for Eric. Bonnie said, what does this mean since the larger volume area wise is under 7,000 feet? Eric, do you know what that would be? And she said that the greater Yellowstone area is what she was considering.
Yeah, hopefully I don't get cut out mid-sentence again. But my slide, I think it might be easier just to show my slide again, which I have it pulled up here. But this slide here was just showing that most of it's actually from that 7,500 to 9,500 feet in the Yellowstone River Basin, being kind of this elevation band here, because that's where we're at in terms of 9,500 to 7,500, and then just most of that contributing area of elevation. So maybe I'm missing part of the question, but yep.
If I can add, Bonnie provided the last column for our Montana Matters, Climate Matters series on what it means for the ski industry. So thanks, Bonnie.
Bonnie's a great partner all over the place. Bonnie, do you feel like he answered your question? Otherwise, we can move on to a couple more.
Yeah, I'll review that slide in greater detail when we go to the recording.
Okay, that sounds good. Thanks,
You
Bonnie.
can give me a call anytime too if you want to walk through it more.
Thanks, Eric.
Sherry, it looks like you had your hand up first. If you want to unmute and ask a question, you can go right ahead.
Yes, I do. So from Eric's presentation, I got the overall sense that, we're above normal, right? But Cathy, from yours, got the sense that, we are in a below normal trend. And so I guess, Cathy, are your statistics, your predictions more for lower elevations, and then Eric, yours are just for higher elevations, or how do you reconcile that?
Well, I can start, Eric. Yeah, Eric's looking at almost day-to-day variation in snowpack. So his is very weather driven, and also varies from year to year. Whereas the long-term loss of snowpack that's a trend, measured over several years. So the two things can be happening. When you show the long-term trends, you can see there's ups and downs, but it's different than looking at it from, really short-term weather events.
Okay.
Yeah. And then from my perspective, it's kind of challenging because it's what I was trying to say is there's enough of a surplus up high that it's currently offsetting like the lower elevation deficits in terms of like this basin wide percentage. I don't honestly think it's like a great situation to be in because it's like we need more snow, especially at all elevations, because I was talking a little bit about soil moisture loss at the lower elevations too when there's no snow on the ground. So and then just kind of finish that off. It's just so early in the season too that I'm just kind of waiting to see how it plays out over the next couple months.
Okay, thank you.
Mm-hmm.
Clinton, it looks like you put your hand up next.
Yeah, thank you. I guess this goes to Cathy. At the beginning of each winter, we keep on hearing about the change between La Nina and El Nino, and uh, I guess my question is, how much does climate change is climate change affecting that pattern, or is it? Um, I guess I'm unsure about how much of a role climate change affects that oscillation, I guess, between back and forth and the duration of each, because they always seem to be um, shorter and longer than other times. And I'm not quite sure what drives that, what determines that. Is that climate change, or uh, if you could explain any and all of that, I would appreciate it.
Well, I wish I could explain it. Let me tell you what I can say. So ENSO, El Nino, La Nina that's interannual variability, right? So it's some of the chatter that you see in the temperature data that is kind of wiped out when you look at the long-term trend. In the past, when we've had warm periods, we've had more persistent La Nina conditions than El Nino conditions. So, even persistent for thousands of years, we've been in a kind of a La Nina mode. But the other thing I want to stress is that ENSO variations are very poor predictors of climate in Montana. It's good in the Southwest, especially. There's statistical robustness to the predictions. It's pretty good in the Northwest, the Pacific Northwest, but it really only does a good job in predicting the climate of very northwestern Montana. So people always are hanging on it because everybody wants something that they can, what you can say is going to happen in the next 3 months, but it's not statistically a very strong relationship.
I wondered about that because this year, for example, they came out with their winter forecast, and what they were predicting for Montana hasn't really seemed to materialize. And now I noticed that they're, at least not in my mind, but I noticed, and I go back and I read what they're predicting for the rest of February and March and April, and what is being predicted in the short term sure doesn't match what they're predicting in the long term. Because they keep on saying this is going to break down and we'll get back into more of a normal weather pattern, but it sure doesn't seem like it from what the
Yeah.
predictions now are saying.
If you look at that map, that circulation map that I showed, that's really probably the best prediction. It's that there's going to be a large blocking high, and where that is will really determine where it's cold and wet. So, in Montana, just slight shifts in the position of the jet stream determine
Right.
whether we get snow or not. And that really blocking high and that big dip in the jet is kind of a La Nina pattern that gets set up.
Hmm. Thank you.
Yeah, thanks for your good questions, everybody. Sale, you had your hand up next. Let's see. Good to see you.
Hi. Yeah. Oh, let me put my hand down. Thank you, everybody. Thanks, Eric and Dr. Whitlock. This has been really helpful. I think there's been a lot of information circulating about like how can we be having such a hard winter when there's so much moisture. And my question is maybe more for Eric, because it's a little bit more seasonal and short term. But as our soil moisture becomes increasingly saturated, what does that mean if we continue having either rain in lieu of snow, or if eventually that soil surface does saturate and freeze over? Um, I guess my understanding is that right now, because things are warm enough, rain has been able to percolate and recharge some of our systems, which usually happens as snow melts when we warm later. But if we were to freeze over now or reach a saturation point, would we then be in a tricky spot, even if we continue getting moisture, if we can't capture it and slow it down?
That's a really good point. Good question. Yeah, it's I don't know how to answer that. I guess I would be concerned if things were frozen and you got moisture on it. It would definitely run off a lot faster. I mean, even think of like a fire type summer situation, burned areas, how fast like moisture runs off because of the hydrophobic soils and st such. Um, it's hard to tell, honestly. Like, I mean, I would hope that things wouldn't be frozen. Like generally the soil surface right at the surface of the ground, even under a snowpack. A lot of times that's like right at freezing, even though the snowpack a little bit higher up might have more cold content to it, closer to the surface. So generally, we're not really dealing with that too much, but I'm not going to say it couldn't happen. And if it did happen, it would be definitely concerning.
Yeah.
Thanks.
If we have the projection for more precipitation in the next 3 months, that's going to come more as rain, right? Or very, very wet snow. So you have to keep that in mind. And the big floods was it 2022, were just that kind of setup, where you got rain on snow events. So stay tuned.
Thanks. Yeah, I'm just thinking about the drought season. Thanks, PCEC and Alicia.
Yeah, good to see you, like I said. Um, it looked like we had a question in the chat from Maria. She said, are the ski areas considered lower elevation since the skiing is not good this year due to lack of snow?
Yeah, I would say I can't agree more. Skiing has been far from great this year. Um, honestly, snowpack percentages are calculated from snow water equivalent. So a lot of times you'll get that and then it'll stop and then things will get icy. It's not like always a super good indicator of like ski conditions because, good ski conditions in my mind are like snow refreshing from a lot of different storms, so powdery. But in terms of coverage, yeah, I mean, you think of Bridger, like what's the base of Bridger? I forget, like 5,500-ish, maybe like tops, so like just under 9. So it is at that slightly lower, especially the bottom half of Bridger. The skiing hasn't been great, really thin, but you get up higher and there is pretty decent coverage, honestly. And unfortunately, Crosscut kind of sits at lower elevation too, so they've been struggling down low. But hopefully that helps answer that question.
Yeah, it looks like Bonnie jumped in there too. For those of you that don't know Bonnie, she's been the sustainability director at Bridger Bowl for a while. And she said that elevation and jet stream dependent this year. Yes, lower elevation ski areas or lower elevations of high ski areas are atypically lower snowpack. Saw some more rain and more warm temperatures overnight. Thank you, everybody, for all of that. Do we have any other questions? Yeah. Yeah, so I will be sending up a follow-up email with a lot of these links, particularly the ones that Cathy was sharing, some that Eric used to like put together his data. We have about 1 minute left, so I'm going to hand it over to Taylor to wrap us up. And thank you again, Eric, Dr. Whitlock. Thank you, thank you, thank you for participating and teaching our community.
Thank you.
Yeah, thank you all for participating. Yep. We wanted to take this time to highlight a few upcoming public events and public comment opportunities that we have. The Gallatin National Forest Avalanche Center is hosting a State of the Snowpack series on January 30th at 6:30 p.m. and it's sponsored by Sidewall Pizza, hosted by Opry Brewing in Bozeman, Montana. And you can stop by to learn about what's been happening with snow and avalanches throughout the GNFAC forecast area and specifically get insights into Cook City area with special guest Nina Marthanel, lead guide for the Beartooth Powder Guides. And then also on February 12th at 6 p.m. at the Lincoln School, our Public Lands Action Network is hosting a public comment writing workshop for the proposed rule in Section 401 of the Clean Water Act. And we'll be sending out an email to members shortly with more details about this event. And we also are having our Ramshorn Classic event on February 28th at the B Bar. There will be live music, food, refreshments, cross-country skiing, hopefully, and a fun time to spend with the community.